So good evening. I have the wonderful, double task of being the last speaker who's holding me back from the tea break, and also the topic of math. So let's try and make it as interesting as possible. Just to give you make sure everyone is selfish interest, everyone's paying attention. There's a little puzzle in there which I'm going to ask you to get involved in. So math phobia is very widespread, and let's start by looking at what has really brought us to where we are today. When we look at the journey of math has been around for thousands of years. We know of many famous mathematicians in ancient Greece, the Roman Empire. All through history, we've had people working in math. And when we look at their work, when we look at their thoughts about math, I've picked up one quotation by Sir Isaac Newton about 350 years ago. He wrote this huge body of knowledge spanning so many different areas of human knowledge. And he says, "To myself I am only a child, playing on the beach, while vast oceans of truth lie undiscovered before me." I just want you to pause and sort of feel the beauty of that thought. The joy, the curiosity that he had about discovering, unlocking the mysteries of the universe. And I want you to cut to this image of this child here who is standing in front of this board, and literally she's at her wit's end. She's like, what are these squiggles on the board? I cannot understand. I cannot make sense of it. And we really need to pause, and we need to question ourselves on what have we done that has brought us here. I'm going to try to put a few explanations which would attempt to sort of explain this journey that has happened in math. What has happened over the last 200, 300 years is that the body of knowledge that we have as humankind has exponentially gone up. So now, instead of wondering what is making the clouds move, or what's up in the sky, or what is making nature work, we've divided it into different modules. There is biology to study this, there is physics and chemistry to study that, there is philosophy, psychology, all of these different fields. And the subject which has suffered the most in this is math. Because what does math study? We don't know. When you think about it, math holds the key to pretty much every subject that we study. But the link has become so diluted, the link has been broken to such an extent that there are unfortunately jokes about it now. You will see these comic strips which will say, oh, why, a child is asking his dad, why do I need to study math? And the dad answers, you will need to teach your child when your child is in school. And the other sad part is, take any math book and open it. The way these books are developed and written, they will start with a concept. They will go on, they will give you a few formulas, and then they will give you a sample problem, right? And the child is supposed to sort of go through this, or hear the teacher go through this in class, look through the sample problem, and then make an attempt to solve the exam or the practice problems that come towards the end of that chapter. And the human brain is very, very smart, right? We are one of the only species that learns, and learns in so many different ways. And what this child has learned through this process of going through that chapter is, okay, I'm going to get a perfect problem. I'm going to get a word problem which has just the right information that I need to solve the problem, no extra information, no information missing. I need to look at it, I need to think back, which formulas am I going to be able to apply in which order to arrive at the right answer. So we have completely lost the plot of what math is about. The second issue is math instruction being disconnected from the child, and that is true for every subject, but more so for math, because with math what happens is, unless you know the preceding concept, you cannot get to the next concept, right? If you don't know addition, you can't get to multiplication. So when we are in that bell curve classroom, when a child has not been able to master the preceding concept, they are completely lost. The learning gap goes up to such an extent that they develop a phobia for math. The minute they are faced with a situation where they are needed to solve a problem, they go into this sort of tailspin where they just put their hands up and say, I can't deal with this. And that is why we get students who, before an exam, you find that they are actually going and memorizing the formulas by heart, when really the day before the math exam should be a holiday for all kids, right? If you know the concepts, you don't need to study it. So now what can we do as educators, as parents, professionals, as a community? What can we do to fix this? I think this is the first thing we need to do. We need to make math real again. Now, this is a very interesting picture. Take a look at it and see. It represents a very fundamental mathematical equation that we have all studied in school. Anybody wants to make a guess? Sorry? Sorry, you'll have to speak up a little bit. Okay, so I'll give you the equation. Look at the figures again. When you look at the first figure, imagine, ignore the colors for a bit so it's easier for you to imagine the first figure as a big square with a little white square cut out of it. So now the area of the figure on the left is, if the big square, the side is x, and the small square, the side is y, the area is represented as x square minus y square, right? Easy enough, right? Now we take the lighter rectangle on the top and move it to the side. The sides are going to match because the longer rectangle has, the smaller rectangle, the longer side is x minus y, and the larger rectangle, the shorter side is x minus y. And so they match, and now you can very quickly visually see that the areas are the same, but now you can see why this equation is correct, why this equation is true, right? The area of the right hand figure becomes x plus y into x minus y. So, as humans, our visual memories are very, very strong. We are not designed to deal with abstract knowledge, but visual memories are very strong, and if we are able to make math real through different means like this, the child essentially starts to be able to conceptualize concepts and apply them much more effectively. The next step, which is more in tune with the theme of this conference, on personalized education. Math especially, because it is so vast and so deep and can be applied to so many different fields, there is no excuse for not being able to find the right content for each child. We all talk about multiple intelligences. We have so much understanding now about how different children work, what is their, what are the components. Some children are good at this, some children are good at that. There is no excuse for not using that knowledge and connecting it to math education. So a child with a high interest in nature, naturalistic intelligence, let us encourage them to look for patterns in nature. We know that nature is abundant with mathematical concepts, Fibonacci series, fractals, all of those things. Music, very mathematical. What sounds pleasing to the ear? What are the patterns behind that? What are the intervals and spans behind that? So we don't have to be the experts. We don't have to be expert musicians to teach math to a musically inclined child. All the speakers who have come before have spoken about the fact that now we have so much content available. It is a matter of finding the right content for the right child. Similarly, it could be sports, it could be a more design-oriented student, even a simple game like rock, paper, scissors lends itself to teach math concepts such as probability, statistics, fractions, percentages, angles, anything that you can name. Once we do that, once we make math real and we personalize it for every child, we hit the next problem, which is the problem of the classroom and having one instructor and 30 students. We are so fortunate to be living in this time where that constraint completely goes away. You've all been hearing through these sessions about personalized learning tools, especially for math. There is so much out there, there is so much coming up. There are adaptive learning tools, there are self-paced learning, there is gamification, and I personally know so many students that spend hours outside of school hours on places like Khan Academy, Dreambox. They are doing math which is grades above. There are students who are using it for remedial. And how powerful it would be if the computation of math, the teaching of the computation of math could move outside of the classroom, and the classroom became the place where we actually are taking that knowledge, taking the student and the place that student is in and applying it to real life situations. When we are able to fix all of these elements of teaching, essentially what we end up with is we replace that fear, that phobia of math, and we bring about that sense of curiosity. We go back to that sense of curiosity and discovery. And not only that, then do the students find math easy, they are not as worried about the exams, but also when they wake up in the morning and they are taking a walk and they see a natural phenomena, say just possibly a line of ants walking outside the window, they will actually stop and think, has anybody modeled this mathematically? Can I do it? There is that sense of curiosity and that sense of wonder that comes back to math. Thank you.